So, session 2012 sodium vapor lamp. We're talking now about the atom. A sodium vapor lamp emits mainly a yellow light called doublet of wavelength. So, we have the wavelength lambda 1 and lambda 2. Other wavelengths are also emitted as those lambda 1, lambda 2 equal 500, lambda 3, lambda 4, and lambda 5. So figure 1 below shows only the yellow doublet. هودي هن اثنين. Okay, these correspond to the yellow doublet of the emission spectrum of the sodium atom. أعطينا هون الجيفن. To what range, visible, infrared, or ultraviolet, okay, does each of the radiation of the wavelengths اللي هن من lambda 1 to lambda 5 belong? نحن we know that lambda that's visible is between 400 nanometer and 800 nanometer. قبل ال 400, so we call it, if it was smaller than 400, we call it ultraviolet. If it was higher than 800, so we call it infrared. Now, if we look here at the values, so في عندنا lambda 1 أصغر من 400 nanometer, so this is ultraviolet. We have lambda 2, it's between 400 and 800. Lambda 3 the same. بينما lambda 4 and lambda 5 هن bigger than 800, so this is infrared. لكن هون if we have to put the range, so we can say part 1, lambda 1, okay, it belongs to the ultraviolet, since lambda اللي إلها is smaller than 400 nanometer if we have to verify. بينما we have lambda 2 and 3 and lambda 3 are visible بما أنه are between 400 and 800, while if we notice lambda 4 and lambda 5 هن higher than 800 nanometer, which means it's infrared. So we continue. Part 2, is the sodium vapor lamp a monochromatic or polychromatic source of light? Monochromatic يعني it only give us only one radiation, only one lambda. بينما if polychromatic, this means we have many lambda. So if we notice here, بالنسبة للsodium vapor, we have many lambdas that are emitted. So this means it's a polychromatic source of light, since we have, or it is formed of many lambda, many wavelengths lambda. Okay. 3, consider the yellow radiation of wavelength سواعطينا, and this is lambda here. Show that the value of the energy of a photon corresponding to this radiation is approximately 2.11 electron volts. So in order to find the energy of the photon, we know that E of the photon is equal to hc over lambda. We have the Planck's constant 6.62 times 10 to the power negative 3, 4 times 3 times 10 to the power 8 over lambda. Now we have to pay attention, we have to convert to meters, so times 10 to the power negative 9. And then we get the answer. هيطلع معنا الانسر 3, approximately 3.37 times 10 to the power negative 19 joules. Now the question is to find it not in joules, in electron volt. So هنرجع نقول in this case that we will multiply by 1.6, we will divide by 1.6 times 10 to the power negative 19. So E photon divide by 1.6 times 10 to the power negative 19, and then we get the answer is approximately 2.11 electron volt. Now, energetic analysis of the diagram. Figure 2 shows a simplified diagram of the energy levels of a sodium atom. One of these energy levels represent the ground state. Specify which one. So the ground state corresponds to the lowest state, which means it's E1. So part 1A, E1 هي the ground state, since it must be the lowest. Now نحكي عن ground state. Part B, what do we call each of the other shown levels? هلا من ال 2 لل 5, okay, so from 2 to 5, هون with the part we call them excited state. So from 2 to E5 بنسميهم excited state, excited level, while the last one اللي هي zero, the energy level zero, so the zero corresponds to what? To ionization level. Now, part 2A, define the emission spectrum. So we know that the emission spectrum هو عبارة عن the set of lines, so the emission spectrum is the set, or is the lines, is the set of lines, if you want to say, or the group of lines. Okay, so the group of lines emitted by the atom. يعني usually what do we observe? We observe a black background. يكون في عندي black, this is will be black background, while there's some lines that are colored lines. Wooden colored lines corresponds to the emission spectrum. يعني هن نتيجة ال emitted photon اللي عندهم some certain values of lambda. So this is why we can see we have a black background, but we have these lines that are colored due to the photon. Each one depends on the lambda that's emitted. Part B, use the diagram of the figure 2 to justify the discontinuity of the emission spectrum. بنلاحظ انه هون emission spectrum هون بنشوف line, هون بنشوف line, هون بنشوف line. So it's not continuous. So I have to look at the diagram here and verify the discontinuity. We notice that انه to each transition، يعني اذا انتقل for example من ال E2 لعند ال E1، اذا صار عندي هيدي الإيميشن حيطلع عندي a certain lambda. Now إذا انتقل من ال E3 لعند ال E1 I'll get another lambda. From E3 to E2 I'll get also another lambda. So بنلاحظ انه these lambda has very specific values, and this is why we can say بما انه we have very specific values, this means that بما انه transition are discontinuous, يعني have specific values, then the spectral lines will be, or the emission spectrum is discontinuous. So here we can say that each transition from higher to lower state, okay, has a very specific value. Which means بما أنه we have a very specific values, which means this explains the discontinuity of the emission spectrum. Okay, we continue. The emission now, part 3. The emission of the yellow radiation of wavelength 589 nanometer is due to the transition of the sodium atom from an excited level En to the ground state. So determine En. Now, in order to find En, نحن بنعرف إنه هيدي اللي هي 589 nanometer. أوكي ديجا كنا نحن طلعنا لها الانرجي اللي لها، بس قبل ما أطلع الانرجي اللي لها أو قبل ما أرجع لها we're talking about emission spectrum. So since we're talking about emission spectrum, this means that the atom was initially at the level E initial, put it like this, E initial, minus, it loses a photon, and then it reached the final state. Now, the E initial is called here En. E of the photon, we already have it. So إذا بنرجع لورا, we have it like معنا 2.11. I'll leave it now like this. And E final قلنا بدها توصل لوين? To the ground state. So which is E1. The question is to find this En. So which means that En equals to E1 plus E of the photon, which means negative 5.14. E of the photon, if we remember, it's 2.11 electron volt. So plus 2.11. And then we get the answer, we obtain negative 3.03 electron volt. This means that this En is E2. So this corresponds to E2. Part 4. In fact, the energy level En, يعني هيدا اللي طلع معنا اللي هو ال E2, okay, is double. And this double يعني هو مكون من 2 level فعليا. This double is constituted of two energy levels, En and E prime N, that are very close to each other. Why? لأنه if you remember نحن كان طلع معنا so I just put the lambda 589 nanometer وكان قالنا كمان إنه we have another lambda that also correspond to the doublet of the yellow اللي هي هيدا 589.6 so we have another one I'll put it prime مثلا 9.6 nanometer so وحدة both okay correspond to the doublet yellow now the question is we have one of them is called En, the other is called E prime N. Okay, the question compare with justification En and E prime N. So in order to compare نحن اثنيناتهم هينزلوا لوين على state E1. So لأقدر قارن we have to know here and I have to look at the lambda prime. So the question is compare En يعني مين الأكبر En ولا E prime N. If I look here, I have lambda is smaller than lambda prime. But we already know that the energies are inversely proportional. احنا بنعرف إنه if I have to write if we have to write the equation شو حنجي نقول إنه E كانت على En minus it loses a certain kind of energy which is E للphoton and it reach E1 واللي هي طلعت معنا this means that E of the photon is equals to En minus E1 but E of the photon is hc over lambda so each time lambda is smaller this means that the energy is higher so هون بمجرد ما احنا عرفنا انه lambda is smaller than lambda prime then directly I can know that E prime N is smaller than En أو العكس which means that this is how عملنا comparing so I just compare the value by comparing the lambdas. The sodium atom being in an excited state EX, so ما بعرف in which excited state, receives a photon, so it receives, this means we're talking about absorption, carrying an energy of 1.51 electron volt and passes to another state EY. So we have EX and it gain a photon to reach another state EY. EX and EY both exist on the diagram and pay attention انه اثنيناتهم هيدا كان excited in the excited level وهيدا كمان excited level يعني انا هون حشيل ال E1 من القصي. Determine the two levels EX and EY. Now in order to find EX and EY we know that the photon is this much so this means that EX minus EY okay or نظبطها like this means that we'll write EY minus EX, okay, this is the final state, this is the initial state, will give us E of the photon, واللي هي 1.51 electron volt. طب لنعرف أي وحدة حتعطينا 1.51 electron volt, let's try. أكيد بدها توصل لوين بده تكون excited level وبدها توصل ل excited level. Now if I do E3 إذا بنجي نعمل نحن E3 minus E2 ما حيطلع الأنسر 1.51 electron volt. So this is not true. Let's continue. What if we said it will pass from 4 to 2? The final was 4, so the initial, and it will reach 2. Then in this case, if we do the calculation, هيطلع عنا negative 1.52 minus 3.03, which is equals to 1.51 electron volt. This means that طلع معي قد ال E of the photon. This means that ال X, okay, sorry. This means that here, if we compare, this is the Y اللي هي 4 and this is the X اللي هي 2 يعني this means the atom was on the level 2 it absorbs a photon of 1.51 electron volt and then it reaches the level 4 so I can say directly إنه لكن EY corresponds to E4 while EX corresponds to E2. Now, part B, this is part A. Part B is the spectral line associated with the transition XY. So قلنا هيدي هي الX وهيدي هي الواي. An emission or absorption line, justify your answer. أول شيء you notice that the energy is increasing. بما أنه the energy is increasing, this means it's gaining an energy. The atom is gaining energy. If the atom is gaining energy, this means it corresponds to absorption and not emission line. So لكن since the atom is gaining energy, so this transition corresponds to an absorption line. لو كان عم يخسر يعني عم ينتقل من ال E4 لعند ال E2, this means it's losing energy. In which form? In the form of photon. So we have, in this case, you call it an emission spectrum.